Hello, welcome to a video presentation or a screencast of the final prototype, which is done by Behangodun Tubu. So this project is a supervised machine learning under classification. This is a phishing website detection using machine learning. So the purpose of this project is to detect phishing web pages or any malicious website. So the first thing that I did was to check the path to see if I'm in the correct folder where I have my notebook and the CSV file or the dataset. After doing that, I started by importing the libraries that I was going to use to load the data, to pre-process and to display the data. After doing that, I started by loading the data by using p.read CSV, and I assigned it to a variable named data. After that, I displayed the first 10 rows by doing data.head. Then I specified 10, which gave me the first 10 rows. I can also do this. I can also do 5. Let's start here, which will give me the first 5 rows of the data. After that, I moved in to display again, but using a different manner so that data will be easier to read. After loading and reading the dataset, I moved on to look at the shape of the dataset, which showed the number of columns and rows of the dataset. Then after that, I moved on to displaying a summary of the dataset by using data.info, which will tell me if I have any null values or any missing values, and how many entries I have from the data and the number of columns that are there. After that, I moved on to data pre-processing, where I will clean the data by applying some pre-processing techniques so that the data can be cleaned before training and testing. So I started by doing a data.describe, which gives us an output of a statistical summary of the dataset, which shows us the count, the mean, and also the max and some percentages of the data. After doing that, I realized that most of the data is made up of zeros and ones, except for domain and URL depth. So the domain column doesn't have any significance to the data to machine learning model training, which resulted in the dropping of the column. So as you can see below, I'm going to drop the column. Then this will leave us with 16 features and a target column. After doing that, I moved on to check for null values or missing values by using data.isNull or data.sum, so that it gives me a summary of all the null values, which was 0, showing us that there are no null values or any missing data. After doing that, data was shuffled so that when training and testing, data can be equally distributed. So as you can see, the rows were shuffled. Then a quick observation from shuffling the data. It shows that the data set has no null values. So further processing will not be done, such as to replace or delete null values. So this data is ready for training and testing. So before that, we're going to visualize the data. So the first thing that I did was to visualize the data using a histogram. After doing that, I moved on to see an overall distribution of the continuous data variables by using a displot. After the displot, I moved on to a heat map to see the correlation of the rows and the columns. After that, I did a box plot. After visualizing the data using Seaborn and Matplotlib, I moved on to training and testing. So the first thing that I did was to import all of the libraries that I needed to train and test. Then after importing all the libraries, I wanted to separate and assign features to X and Y, which was done here. After that, I wanted to split the data into a training and testing, which was split into an 80 and 20%. 80% which is for training and 20% which is for testing, which is done here. After doing that, a few models were selected to fully test and train the models. So I started with logistic regression, decision tree, random forest, k nearest neighbors, and XGBoost. Before I could use the models, I created holders to store the model performance results so that at the end of the training and testing, the models could be compared and contrasted to see which model performed better or well against the dataset. After doing that, I started with logistic regression. Started by initiating or instantiating the model, fitting the model, then predicting. After predicting, I printed the output of the model, which showed the accuracy of the model, which was 0.797, and also it showed the accuracy of the training data and accuracy of the test data. Then after that, I stored the result. So with this feature, you have to store it once so that it doesn't duplicate. If you store it or you run it a couple of times, it will duplicate, and then you're going to have more results showing logistic regression. After that, I moved on to decision tree classifier by importing, initiating, fitting, and predicting, then again printing the model or printing the result, which shows the accuracy, which is 0.8005, the training data 0.814, the testing data which is 0.11. Then I further moved on to check the feature importance in the model to highlight which features may be most relevant to the target by doing as you can see, after doing this, I stored the data again. Then I moved on to a random forest classifier. I initiated the model, fit the model, predicted, then printed out the results. So the accuracy of the model was 0.8005 as of logistic regression. The training data, which was 0.819 and 0.818. Then I did the same thing. I checked for future importance. After doing that, I stored the model. Then I moved to k nearest neighbors classifier, and I did the same thing. I initiated, fit the model, predict, then predicting the target value for the model for the samples. Then after that, I printed the results, which gave us 0.805 for the accuracy of the model, which is the same as decision tree, random forest, and logistic regression. So after doing that, I checked also for the feature importance, then I stored the model. Then the final model that I used was XGBoost, which was new to me. I had to do a few experiments so that I will learn more about XGBoost classifier. But the process was the same. I instantiated the model, I fitted the model, then after predicting, I printed the results. So XGBoost had a more accurate result, which was 0.857. Then the training was 0.869, the testing was 0.857, which showed that this model had the highest number of training and testing compared to other models. Then I stored this. So to now understand or to compare the models, a data set or a data frame was created to store all the data that was being stored. Then I printed out the results, which showed us the training accuracy and the test accuracy. After that, I sorted the value in an ascending order, which showed us that XGBoost had the highest training accuracy and the highest test accuracy, followed by random forest with 0.819 and 0.818. After doing this, I imported a pickle so that I will save our model, which is XGBoost. The reason why this has been done is that we are able to deploy or run the model after saving the project or after the project is done. So this is the end of the project on Jupyter Notebook. I will now move on to showing the deployment part.